Welcome to Unit 5, which is called Measure and Geometry of Real Shanghai Mathematics Practice Book 3.1. This consists of 7 sections, and without any further delay, we'll continue. So the first one is called Introduction to Kilometers. That's the first one. So just a quick reminder regarding this. We've covered a portion of this before. So K here stands for kilo, so that usually means 1,000. So kilometers is equal to 1,000 meters. Okay, and you need to remember that that's 1 kilometer. 1 meter is equal to 100 centimeters. Okay, and 1 centimeter is the same as 1 millimeter. Sorry to say 1 millimeter. 1 centimeter equals to 10 millimeters. Milli here stands for a thousandth of a meter, or 1,000, or a 1,000 millimeters equals 1 meter. But as long as you know that, you should be fairly comfortable with this, and it's something that will come again and again. So question 1, write the appropriate length unit, meter or kilometers. So again, getting you an idea of kilometers is much bigger than a meter. It's 1,000 meters. So write about, okay, so what this is, a cyclist, write around how many 300 watt per minute. So in a minute, the cyclist will not be able to 300 kilometers, so it's going to have to be 300 meters, and the car goes much quicker than that, and which is about 80, and it's over a longer period per hour, so that would be 80 kilometers. Fill in the missing numbers. 10 times 100 meter equals 1,000 meters, and this is the same as 1 kilometers. To be another, have to run a total of 1 kilometer. So 1 kilometer is the same as 1,000 meters. So that have to be 2 complete laps, because 2 complete laps will be 400 plus 400, 800, and then another 200 meters, and you'll get a 1 kilometer. 3, convert. So I'm not going to go all through all these questions. So I'm just going to pick out some that you're particularly struck on, and from the information I provided, you can't work it out, then let me know. 50,000 meters equals how many kilometers? So to get from kilometers to kilometers, because 1 meter is 1 kilometer is 1,000 kilometers. First, you think is the answer going to be bigger or smaller? It's going to be obviously smaller, so it's going to be 50,000 divided by 1,000. And we have explained this previously. Divided by 1,000 means removing 3 zeros. And then question 4, greater than or equal to, again, should be fairly straightforward, but you need to, if you're getting confused, you need to make the units the same. So for example, 15,000 meters, take with 5,000 meters, 10,000 meter. 10,000 meter is the same as 10 kilometers, because 10,000 divided by 1,000, and that is obviously going to be greater than 5 kilometers. And then you get question 5. So you can do that yourself. Question page 67, level B. Some people stand in line hand in hand, as shown. How many pupils need to stand in a line to make about 10 meters long? Okay, so this is if you have in a class, how many pupils. So I would go with, just pretend that the number in the picture is the right one, so just go with that. That would be easy, unless you've got the ability to do it. So here there's 3, 6, 9, 10. So say there's 10 children that are needed, and then to make it a line of 1,000 meters long, you would need to have 10 times that. But the answer might not be right, because it's a little bit tricky with these kind of questions. So I won't go into the issue regards to possibility of level B not just being times by 10, because there'll be a gap between the starting points and not identical. But yeah, if you can't do that, that's not a problem. Your answers might shed a light, or they may not. Okay, and as I say, level B's are optional. Moving on to the second part, which is called meters and centimeters. So we have done this before, and it's just a bit more repetition in regards to that. So you use a ruler to work out how many centimeters are there. A length of a skipping rope is roughly how much. So is this going to be centimeters or meters to be put in there? So clearly it's going to be centimeters. Height of a flagpole is going to be 15 meters. So it's quite high up. And length of an eraser is 4 centimeters. And then question 3, again, try and get the units the same. So for example, the last one, 1 meter 65 centimeters and 1650 centimeters, you can put them as the same unit. So let's convert the 1 meter to centimeters. That'll be 165 centimeters. So obviously that's going to be smaller than 1650 centimeters. And question 4, one is taller than the other, so you just have to subtract. Again, convert to the same units if you're getting struck. And level B would be a rope is 10 meters long. How many centimeters are left after Laura cuts off 35 centimeters? How many centimeters are left? Okay, how left, meaning how much is remains. So convert the 10 meters to centimeters. So that's 10 times 100, which is 1,000 centimeters. And then take away that from 35, and that would be your answer. Write the lengths in the correct order. So again, if you're confused about that, convert them to all units, same units, so 200 centimeters for 2 meters and 120 for the other one, and 210, and that will help you to write the largest one first, and then the one smaller than that, and so on and so forth. And question part 3, symmetrical shapes. So these are to do with symmetry. Where are we? Here. Okay, so symmetrical shapes. Which are symmetrical, which are not symmetrical. So symmetrical shapes are which look identical to each other when they have a line of symmetry through them. So for example, if it's a square, okay, so you have to imagine with this is a perfect square, which this isn't. So line of symmetry would be here, right between here, because if you put a mirror here, you would see this side and that side look identical, and the shape would look the same. You can have also mirror line there if it's a perfect square, and a line there. Sorry, going straight to the middle, straight to the midpoint. So that's how you do symmetry. And so for the examples there, if it's symmetrical, so the first shape will be symmetrical, and the symmetry would be based down the center, and you can use your mobile or to put it right in between, and then see if the picture looks the same on both sides. That will give you a clue, particularly when you're doing it initially. Okay, so all those seem to be symmetrical. For question 1 and to question 2, draw the lines of symmetry of these shapes. So 2A is symmetrical, and it would be a horizontal line to give you symmetry. That would be only one. And B has 2 lines of symmetry, which is a rectangle, horizontal, and a vertical one. And the square, as we've shown in the diagram, actually has 4 lines of symmetry because the diagonal is also symmetrical as well. And then question 3 shows you what to do in terms of doing symmetry. So the other side will also look the same, and it's about copying the picture from the symmetry line. Again, should be fairly straightforward. If you do struggle with that, you can look at the answers, or perhaps we should do one here. So for example, symmetry line here, if you've got one square colored here, then on the other side of the symmetry line, a square will also have to be colored. There's 2 here, and then 2 will have to be here. So all is according to the symmetry line. That's how you're going to get a symmetrical line. 3 here, 2 here, 1 here, and you can see the kind of shape that will make. And then you've got a section called a quick practice. Can you draw a symmetry line in these shapes? There you go. So again, use the ruler if you're getting confused, and that'll give you an idea what symmetrically is. So all of these seem to have a symmetrical line going vertically downwards. Are there anything in addition to that? You can use your calculator to double check them. That will also give you a clue what the shape would look like if they were symmetrical on any other axis rather than a vertical line, if there were any. And then moving on to 4, and this is called classification of triangles. So we have done some of this, and I believe they're just adding to this, so we can cover this. Look at the shapes below, read the description, write the number of shapes. So okay, they just want to know about right angle, acute angle, obtuse angle, isosceles triangle and equilateral triangle. So we have covered some of this before. So triangle has to have three straight sides that are connected to each other. Okay, so that's a triangle. And then this angle, if it's less than 90 degrees, so let's go with one of the angles, for example, here is 90 degrees. That's called a right angle triangle. We draw it like this, okay, like a square here, and that'll be a right angle triangle. And this angle, if it's less than 90 degrees, like here, these will be acute angles, all three acute angles, so this will be an acute triangle, right angle triangle. And if we get an angle which is bigger, so this is an obtuse, we'll have one obtuse angle, and these two will be acute angles, but still called an acute angle, and all of these should be connecting. Okay, so there you go. The other two that I've mentioned that are important triangles to be familiar with is equilateral triangle. So if all of these angles, and we normally show the angles like that, all of these angles are the same, then this is called equilateral triangle. Remember, all triangles have a total angle of 180 degrees. And because all of these are the same, then equilateral triangles, always their angles are always 60 degrees. Okay, and that's the degrees sign that we put, so it's 60 degrees, just a small circle there. And then if you've got the other type of triangle which is called isosceles triangle, which has one line of symmetry. So if you put a line through there, that looks the same, and it's called isosceles triangles because that's symmetry really. And what that means is these two angles are identical. Again, these two angles plus that angle will make 180 degrees, but these can vary. So these could be potentially 50 plus 50. If that's the case, this would be 80. If this is 40 plus 40, then that one would have to be that would not work. That probably wouldn't work. 40 it's probably got to be more than 45 degrees. It has to be more than 60 degrees. So yeah, so if this is 70, then that would be 40. Yeah, and so on and so forth. So that was classification of triangles. So if you just cover some of the triangles here, triangles, right angle triangle here, any of them a right angle triangle, you need a set square to see if that's the case. But the triangles are there, so there have to be three parts connected, three lines. So some of them are not even triangles, and 7 looks like perhaps an equilateral triangle. Again, you can have a protractor to look at the angles to work that out. A triangle too is shaped and closed by how many? 3 line segments, okay, which has 3 edges and 3 angles. So edges are the lines themselves to the sides, and the angles are obviously the pointed parts which give you the angles that we talked before. If triangle has exactly 2 equal edges, it is what triangle. Okay, so that's the other thing we did not mention. The way these angles will also be the same, and this also means that these, for an equilateral triangle, this will also mean that these 3 sides are all equal as well. And for isosceles triangles, as I said, it's symmetrical, so actually this side and this side are also equal in terms of length. That's what happens when you get a isosceles triangle. And for this one, again, all 3 sides are the same. That's how you get an equilateral triangle. And so that's what's referring to here. Exactly 2 equal edges is the isosceles triangle. Exactly 2, not 3. A triangle with 3 equal edges is called a equilateral triangle. It's also called which has a line of 3 equal edges is called an equilateral triangle. It's also called which has lines of okay, so I'm not sure what the other term that you're referring to. In terms of lines of symmetry, you would have 3 lines of symmetry. So you have one going through there. Shall we draw these? So one going through there, one going through there, and one going through there. Okay, we're going through this point. So you have 3 lines of symmetry for an equilateral triangle, and for an isosceles triangle, one straight through there, and that would have to be a right angle there. Okay, so that's question 2. Question 3, tick true. Every triangle is a symmetrical shape. Now every triangle isn't. Only the ones we've shown. All isosceles triangles are acute angles. Are acute triangles. Well, none of them can be more than none of the angles can be more than 90. Is that true? No, that's not true. So they don't have to be acute triangles. So we could have, for example, a shape, okay, something like this. We could imagine that this one and this one is the same. If that's the same, because these two lengths are the same, that this would be an obtuse triangle, but it's also an isosceles triangle because these two angles are the same. So it doesn't have to be an acute triangle. Three sides are equal, three angles are equal. C, so that's true. Draw a line of symmetry, so it should be straightforward. Line of symmetry straight through the down the middle, or equilateral triangle. We've done that before. Question 5. You fill in the missing numbers. Isosceles triangle. So if it's a isosceles triangle, and that's 4 centimeters, the other one will have to be 4 centimeters because the symmetry and for B is going to be 3 centimeters. In the diagram below, there are how many isosceles? So these are going to have to be 4 isosceles triangles. Two of them are identical to each other. So 2 pairs of identical triangles, but all of the angles, as you can see from the shapes, are going to be the same. A triangle can be folded in 3 different ways. I'll let you guys do that. And level B, in this diagram, there are how many triangles? There are how many? Okay, so a bit more trickier ones, so just be careful of that. So you can count the individual small triangles, 1, 2, 3, 4. You also got a larger triangle, and they also got smaller ones. Just quickly, I've got 4 here, 6, and then the largest one 7 I've counted, and then you can check which one. Diagram on one side there I'm trying equal triangles, 2 centimeters ones. So 2 centimeter ones are the larger ones. So again, there might be some overlap there, so you can work that out yourselves. If it's tricky, not to worry. The same level B are much trickier usually and not essentials to do. Moving on to 5, which is area. Draw and color. Color the inside of the island green. Color the pier red. Color the beach yellow. Compare the size of the beach, the island, pier. The area of that is bigger than the area of that, and so on and so forth. So area just generally refers to the kind of squares that you can make up the shapes with. And so the beach will be larger than the island, which is larger than the pier. How large are the shapes below? Write the number of squares. So you can see A, count the number of squares, and then put that down. And B would be count the squares and write those down as well. And where you've got half a square, then it would be half and a half would be 1, and then the other one plus another one would be 1, and the other one plus another one would be 1. So some of them two I mean, if you look at 2b, you'll understand what I'm referring to. Some of them are half, some of them are 3/4, and the other one is a quarter in terms of the shape. So you need to add them in that particular pattern. And question 3, which is larger shape, A or B? And that you know by counting the squares. Work out the squares, and then from that you can see which is larger. And in terms of counting the squares for particular, like the shape for A, for 3A on page 75, you've got a shape. The bottom here, you've got a square, which is. Shall we do it? Okay, let's do it with a straight line. Make it easier. So we've got you've got a square here, which is fine, but then next to that square you have another square, but it's not a complete square, okay, because it's going all the way here to here, and then there, and then there's a line here. So this one plus this one, which can be fitted at the bottom, will be 2 squares. So this is 1 square, and that plus that is 2 squares. So that's how you need to sort of count some of these, and that would probably help you with 2b as well. And then whichever one has the more squares, then that is going to be larger than the other. Quick practice: draw a shape that has an area of 10 squares. So wherever shape you want to do 10 squares, you can do it a rectangle shape if you want to, or however you want to do it. Use halves if you want to do that. And then moving on to 6, which is called areas of rectangles and squares. So these are ones that you can particularly work out. The area of a surface of your thumbnail is roughly about how much? Okay, roughly about how much? So if you look at your nail or any shape, let's erase that. Any shape, you can make it into a rough rectangular shape. How big is that? Is that one? If that's 1 centimeters and that's 2 centimeters. So if this is 1, this is 2. and that's 1. And the area, the way we do area is this, the length times the width. So the area would be, again, these are centimeters. These are all centimeters, 1 centimeter, and that's centimeter as well. So the area will be 2 times 1, 2, and centimeter for area, because we times that and that, the units have been times by them together as well. So we write that a little bit there, then we know this is referring to as the area, 2 centimeters squared. Okay, so area is probably most likely going to be A, 1 centimeter squared, and D can't be right because we're talking about area. And then moving on to B, the stamp and the picture to the right, you can use a centimeter, you can use your ruler to help you out. Roughly, that's going to be whatever that is. So if that's 3 by 2, then it's going to be 3 times 2, which is 6 centimeters, if that's the kind of shape. Question 2, a rectangle with length 4 centimeters, width 2 centimeters, so 4 centimeters long. Each one of those squares is a centimeter long. Area is going to be 4 times 2, that's going to be 8. So it's how many squares are, and you can see from the picture there that 8 squares would have been colored in or consist of the rectangle. Square 3 centimeters all the way around, so that'll be 3 times 3, 9 centimeters squared. The measure and 3 should be straightforward measuring, and B, draw an area 12 centimeters. So to get 12 centimeters square, it'll have to be a shape like a rectangle one, which is going to be 3 by 4, or because 3 times 4 is 12, or 6 by 2, it's going to be 12. And then moving, magic secrets. The secret of page 93. This picture, look at the picture carefully and you will understand the secret behind the magic. Okay, so we don't have the other stuff, so we wouldn't go through that, and go through page 78 and the last part, which is called square meters. Okay, square meters. So just the way we've done centimeters squared, now we do square centimeters, square meters. So that's the same thing as the one we've shown before. So let's say this was meters, it would be 2 meters times 1 meter, that'll be 2 meters squared. And the way to write that again will be m, small m for meter, and then the squared bit is there written here at top. There, the little 2 at the top is referring to squared. The area of the square table is about 1 meter squared, and the classroom is going to be 40 meters squared, roughly speaking. Those are the units, and that's how we write it. Or you can write square meter. I'm not sure if perhaps they want you to write square meter there, but either way should be fine. Question 2. What have we got? What is the area of the living room? So the living room, it seems like it's 3 centimeters wide and 7 centimeters long. So it'd be 3 times 7, which is 21 meters squared. Again, you gotta have the right squared bit there. And then compare the areas of the bedroom, which is larger. So bedroom is 6 times 4, which is 24 centimeters squared. Sorry, 24 meters squared. Which one's larger? And the total area of the grass. Again, the grass, we can have, look at the diagram, you can see 6 meters long, 15 there, and there's 2 meters there. So the easiest way to do this is to do the whole rectangle 6 times 15, and then work out the path and remove the path. So 6 times 15 would be the whole area of those big rectangle, and then work out the area of the path, which would be 2 times 6, which is 12. So work out the area of the grass and then take away 12 meters squared from there, and that will give you there. And see, the area of a playground is 260 meters squared. The width of the playground is 9 meters squared. What is the length? So it just be what number times by 9, because it's 261. So it's 261 divided by 9. And you can use the bus stop method, which we've covered before, to work that out. And then level B and the last bit. This is a rectangle. The field length is 8 meters. Width is 5 meters. The square paddock is fenced off of the maximum possible size. What area of the original field is left over in the square meters? Square paddock is fenced off on the maximum possible size. What area of the original field is left over? So I'm assuming they're making a square, and the square is probably going to be 5 by 5 square. So the leftover field will be 8 times 5, 40. Take away 5 times 5, which is the padded area. So that'll be 40 take away 25, and you can get that as your square meter. And with that, we'll end here. Thank you for your time. Please like and subscribe and share the material, and your comments will be much appreciated.